Good evening, ladies and gentlemen. My name is John Holler. I'm the president and CEO of the museum, and on behalf of the trustees and the staff and the fellows and everyone here at the museum, it's really an honor and a privilege to welcome you here tonight. It helps in endeavors like this to have a great friend and a partner working alongside you, and no one could be a better friend or partner in this anniversary than John Iwata. John Iwata is the Senior Vice President for Communications and Marketing for IBM in New York. He reports directly to the chairman, Sam Palmisano. He leads all of IBM's marketing, communications, and citizenship programs. He sits on two important IBM committees, managing operations and strategy, and he is the chairman of the IBM International Foundation. So John is a very busy guy in the world of IBM, and it's a big world. John is here to give an official welcome from IBM. Please join me in welcoming John Iwata.
Thank you, John. Good evening, everyone. John is right. When I had the opportunity to be a part of this celebration and anniversary, I leapt at the opportunity because of its significance, but also I never turned down an opportunity to come back home. And it's wonderful to see so many friends from my early days at Allen Research. I want to thank John and the Computer History Museum for organizing and hosting this wonderful celebration this evening, and for recognizing one of the great teams in computer history. I'm honored to represent the current 403,000 employees of IBM and the 900,000 retirees and alumni of our company in thanking the 1401 team for their contributions to our industry, to our company, and to the world. The 1401, as we all know, was really the first business computer that brought tremendous computing capability to a whole new range of business customers. But there are many more people here tonight who will talk about the significant technical and business breakthroughs of the 1401, and I will leave that to the experts. For me, what the 1401 team represents is something more. I think of them as IBM's version of the Mercury astronauts, pioneers who paved the way to great things. They were a team that thrived on challenge, they were driven by curiosity, they were devoted to meaningful innovation, and they aimed very high, as we will remember tonight. They wanted to change the world, and they did so. So when I look at the team that developed the 1401, what's amazing and inspiring to me and to many at IBM today is not just what they did, but what and who they are. They are what we mean by IBMers. IBM is going to be 100 years old in 2011. And as we've been reflecting on what our company has done for the last 98.5 years, we pause on moments like this and achievements like the 1401. Not just for the technological advances, which were groundbreaking, not just for the impact on business, which was deep, but for the impact on IBM itself. This team embody the great company that we hope to become again in our time. A few months ago, I had the opportunity to visit with the team in Endicott, New York, where the 1401 was created. It was a wonderful afternoon I spent with them, and I'm delighted to say that many of those people, our colleagues, are here with us this evening. While we were in Endicott and while we were all together, we took the opportunity to capture a few of their thoughts and reflections on camera that day. And I'd like to share some of that with you now. Thank you, and congratulations to the 1401 team.
I joined IBM company in June of 1958.
About June in 1948.
Started in 1957.
I started with IBM June 4th, 1956.
I started at IBM in June of 1959.
I completed 4 years of service with IBM.
Didn't think I was going to fit in with this white-shirted, tied group.
They were ordinary people from ordinary places. They were young, smart, and eager. They began as students, clerks, draftsmen, apprentices, but they would eventually become pioneers. This is the story of the IBM 1401, a milestone in the history of technology, a machine that would revolutionize business, ushering in the digital era. And it all started here in Endicott, New York.
When I first started, I didn't know anything. I was so green, I didn't know what it was to work for a company. I mean, I was a 22-year-old kid.
At the time I accepted the position with IBM, I had no idea of what I would be doing at the company.
My boss was Fran Underwood, who is called the father of the 1401. He called me into my office the very first morning. He says, IBM doesn't know this yet, but you're going to be working on a machine that's going to be the biggest money maker that they've ever had. This machine is going to turn this town on its ear.
The machines that they had prior to the 1401, they had a board that you could set up by plug wires and tell the machine what to do, but it was relatively slow.
The 1401 was the first transistorized computer that anyone was going to have built, and IBM was, of course, the leader in that area.
I'm not kidding you, there was a tremendous excitement going on. I mean, there were people that almost got into fistfights, not because they each wanted to do their own thing, but because they each wanted to do it what they thought was the best way.
This was to be the first machine that was going to be applicable to both business and industry.
It did business accounting that all businesses need to do. Keep track of records, payrolls, logistics, all of that type of stuff. And it could do it fast.
The 1401 system consisted of the computer part. 1402 was a card punch reader, which was the way you got information into the system and out of it. And my part was part of a 1403 printer.
1403 was probably one of the first high-speed printers.
It allowed businesses really for the first time to compute their bills, and the printer was the means of getting it out to the customer.
We pretty much understood that not only was it the electronics, but some of the other things that the 1401 presented, like the being able to store and retrieve data on disks, which was a really significant kind of contribution to the data processing, if you will.
It did have a big impact ultimately on the start of the computer age, I guess.
This, then, is the new IBM 1401 data processing system. It will give you powerful data processing ability with great reliability of components, low power consumption, reduced air conditioning, and much smaller space requirements.
I've heard we sold over 10,000 of them, which was the first time we got there, which was good business at the time.
There were more 1401 sold than all the computers in the world put together up to that time.
You'll find that people that worked on the 1401 say that that was a very important era in their lifetime.
It's unbelievable almost to me today to see how we were able to do it.
I love to talk to people about what I had to do. I can point to these various machines and tell people, well, this is what I did.
We were proud of being an IBMer, and we boast of it.
I've worked 53 years straight. The most time I ever took off was 2 weeks. And I never missed a full day of work, ever. I missed 2 half days. And personally, that's my proudest.
This is an ad that appeared in college magazines as a recruiting tool. And the reason I'm the person here in the ad is because I was a designer on the 1401. That's what I worked on.
That's what I worked on.
That's what I worked on.
I'm an IBMer.
It's my pleasure now to tell the story of another IBMer. About 5 years ago, a museum volunteer named Rob Garner placed an ad in an IBM alumni publication, and he was asking for volunteers to help form a team to restore an IBM 1401 that the museum had obtained or was about to obtain from Germany. And I learned from Rob the other night and everyone who was involved that they thought they were in this for about 12 to 18 months. Typical. 5 years later, under his leadership, that team has not only restored that first 1401, but it has obtained and restored a second. And in doing so, they have helped to educate thousands of people about the history of that era, the technology that made it happen, and the benefit of teamwork and self-reliance. I can't say enough about the work that Rob has done organizing this anniversary week and this evening. The fact that we are all here tonight and our guests are here on this stage is entirely a tribute to Rob Garner's absolute determination to make this event happen. He exemplifies what a single, passionate volunteer can mean to the life of an institution like ours. I hope you'll take a few moments to read about his 32-year career in your programs tonight, a professional odyssey that has taken him through some legendary names, Xerox PARC, Sun, Brocade, and yes, IBM, and in his abundant spare time, to the Computer History Museum. Rob is going to be the master of ceremonies from here on out. It's my pleasure to say an enormous thank you to him. Please join me in welcoming and thanking Rob Garner.
John, thank you for those very gracious words. And the other John, that was a A-class production. Just incredible. That was okay. You've got us all in. You got these guys all in tears before they start. So, all right. Well, I am one of the luckiest guys on this planet. One of the bylines of the museum is "History lives here," and we restored these machines starting in 2004. And I asked, okay, it's nice to have hardware, but where are the people? I had read names in the history books. And it's like, where are they? I mean, okay, this is Silicon Valley. It was done on the East Coast, but where are they? So I took it upon myself to start to look for the founders of the 1401. And I was successful. And they're on stage tonight. One gentleman is in the audience, and about 10 other people from the team are here. I can't tell you how honored I am that they were able to come out here and talk to us tonight. So we're going to have each of the three individuals on stage. Chuck Branscombe on your far left, Fran Underwood on your far right, and Shel Jacobs in the middle give a talk about their area. They're all good talkers. Take notes around midnight. We'll give a quiz. Seriously, we'll try to get done as soon as we can. And I'm going to first start by introducing Chuck. Chuck's going to go first. Chuck joined IBM in, well, I could say 4 years before I was born, but then I'd give out my age. Okay, he was born in 1950, and I'm sorry, he joined IBM in 1950. He's not that young yet. He really had gotten a lot of experience with unit record equipment before then, and so he knew what he was getting into, and he knew he wanted to work for IBM, by the way. And he soon found himself head of accounting machines. He soon found himself actually with this innovative new program that was going to be an inflection point in history, and these guys will tell you they knew that. So he became the program manager of the 1401. Later, he became president of the Systems Development Division, which is the big all development in IBM during the 60s. And then after that, he did a variety of positions, including the General Systems Division, where the low-end systems were a big part of IBM's future. And I'm going to have Chuck come up now and take the podium.
Good evening. I would be remiss if I didn't right up front thank Robert Garner and the Computer History Museum for highlighting the 1401. Most of us on the 1401 program had many great thrills back in the 50s and 60s. But I assure you that never did we expect to have another great thrill 50 years after announcement. And I assure you it is a great thrill to be here tonight. Since we're in a museum, I thought I would take a moment to just talk about a little history of the accounting machine, or tabulating machines as they're initially known. And I'm going to only talk about control because we don't have time to go into history. Mr. Hollerith started this progress in the 1890 census. He had a machine for that application, and it had been estimated it would take 13 years to compile the results of the 1890 census. With his machine, it was finished in 3 years. He got to business again in 1900, but he obviously began to think that he needed a more flexible machine because his machine initially had one application, hardwired internally to do the census job, nothing else. So in about 1906, he brought out a machine where he brought some hubs out to the surface of the machine so the customer could now have a different application program. Now, looks like he was have to get down on your knees to program it, but at least there was some flexibility. About 10 years later, 1916, he brought out another machine that had a removable control panel. So now the customer could have a panel in running an application, have a pre-wired panel ready to go in, and switch over to a new application quite quickly. The IBM 400 series was the sort of the workhorse of the accounting machine world in the 30s and 40s. First version came out in 1934, and the final version, I think, in 1948. I suspect many of you have not seen a control panel, know what a control panel looks like. We have an image here of a fairly simple control panel. Those of you that do know that there are some that are much more complex than this, and the wiring looks like a bunch of spaghetti. But this was the way to control the machine in those days. The 407 came out in 1949 and shipped in 1950, was a very fine machine, high quality, 150 line a minute printer, and was a very successful machine for IBM. During the first half of the 50s, IBM tried some thrusts at a new accounting machine. One of them was called a transcriber that I spent some time on. It was, I guess today you would describe it as a mechanical monster, and it was properly terminated. Another one was visualized to have 4 or 5 models, with the entry model being an accounting machine. There's very little information about the low end because the top part of the line was a big computer, and they spent most of the time naturally on the computer. But they did mention that the entry machine, the accounting machine, would probably have to have a control panel because they couldn't afford stored programming. So for 40 years, accounting machines have had removable, external removable control panel as a means of control. IBM put out some major products in the 50 to 55 range to focus on the business world. 604 calculator came out in 1948. It went into a punch card installation as just an added function calculation. More function, more cost. The IBM 650 computer came out in 53, and it was a computer and brought a significant additional function into the punch card world. But again, it did not replace the accounting machines. It used the accounting machine for its printing. And so it really didn't change the nature of the unit record installation or the punch card installation. 705, a big machine, came out in 1954 for the very large punch card customers, unit record installations. Very good machine, very expensive, and the mass of the unit record world could not afford such a machine, and so they were still in the same position. San Jose here put out the 305 in 1956. It was the first random processing machine, the first disk file machine. And it was oriented for slow-speed transaction processing and did not attempt to replace the unit record machines. As a matter of fact, none of these machines was focused on replacing unit record, but they all were very successful in their intended purpose. In 1950s, about mid-50s, IBM got a wake-up call. A French company called Machines Bull introduced a product called the Gamma 3, which is a calculator actually attached to their accounting machine. And the IBM Europe people were very concerned about this, and I actually think I found one of the charts. They were concerned that IBM domestic didn't really respond to the European requirements. And so they came forth to the corporation to alert the corporation that there's a competitive threat and we got to do something about it. That led to a large planning effort between Europe and the US. That led to a system development plan called Worldwide Accounting Machine, or we call it WAM. The processor for that machine was assigned to the French laboratory in Paris. The card reader and printer was assigned to the German laboratory right outside Stuttgart. Mid-57, I was named the area manager of accounting machines, and I ran across a quote just a short time ago that came out in 1957, but if I had seen that quote at the time, maybe I would have refused the job. It was a quote by the business editor of Prentice Hall Books. I hope you all can read that. I've traveled the length and breadth of the country and talked to the best people, and I can assure you that data processing is a fad and won't last out the year. In my first meeting reviewing the WHAM, that was my first job, was to review the WHAM. Is it on schedule? Is it the right product? Is it meeting its costs? My first meeting was in Paris in 1957. We started the meeting, the product planning manager for IBM France was there, and he started the meeting this way. He said, "The Russians put Sputnik up yesterday, and it goes around the world, beep, 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 and when it goes over the USA, it says, ha, 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 ha." Fortunately, the meeting got better after that. But it was the space age, and so you can see where Franz Underwood's acronym for became the 1401, Stored Program Accounting Calculating Equipment, it was known as a space machine throughout development. In reviewing the WHAM program, first went to the French lab in Paris. They had done some creative work, and they had tried to make the best use of a control panel, but it in fact was still a control panel machine, and technology was on the move, and my conclusion was that was not going to get the job done. Went to the German lab. By the way, they had very good engineers and very good talent. They had done some good technical work on the printer, and actually used as the base technology, some technology that was developed in the US by a guy named Bud Beatty, but it really stretched it to run 300 lines a minute, which was their target, and it was clear it would have a lot of maintenance required in the field. So my conclusion again, and I recommended that we terminate the WHAM program, and here we are now, late third, early fourth quarter 1957, IBM's largest revenue base had no new machine in development to move it ahead or protect it. When we began to focus on that problem, we focused on the punch card or unit record installation in total. We were not interested in building an accounting machine. We wanted to take these people, there were thousands of them of this type, we wanted to take them to a whole new world. And so we established, by the way, having that known target, what we were trying to do, and we understood it pretty well, was a great advantage to us. Fran had spent a lot of time associated with punch card equipment. I spent 12 months in the machine records unit in the Army, which is IBM equipment, thanks to Uncle Sam. And it helped us to have a target and to arrive at a set of objectives that if we could meet those objectives, we were very confident that we were going to have a big impact and move thousands of those users to a new world. The objectives included the function we needed, and we had to put a good handle on that. The cost, very critical. We looked at a couple of counting machines, a calculator kind of installation. It looked like $2,500 a month if we could give them a 600 line a minute printer, a card reader punch, and the processing unit for $2,500 a month, we would have a big deal. So that was our target. Simplicity. The unit record, well, most of the industry had no experience in computers in those days, but the unit record people, of course, were experienced with the punch card machines and control panels. And so we knew that we had to have a simple machine that would fit into their environment. Schedule was rather important since we were behind the gun. We etched those objectives in stone, and in spite of the fact that some people wanted to change them and so on, we were very adamant in maintaining that same set of objectives throughout the entire program. So we had seen incremental enhancements in the accounting machine area, a little more function, more price, right on and on. But we knew that it was time for a dramatic change, a change to the new world. You might say a discontinuity, like these rail bumper cars going into Jim and Fran's garage and a rocket coming out the other side. Mentioning Jim and Fran, they key people on the program from the outset, and I want to spend just a minute on the two of them. Fran had been working on a unique stored program for some time and felt that we had great potential to meet the cost objectives. It used precious resources very efficiently. You'll see in a minute what I mean by precious resources. Variable field length, punch card world is variable field length from the word go, and so it had to fit in that environment. It could be implemented inexpensively. It had excellent print editing, probably the best print editing, well, a lot better than many have come out since. And it was the simple thing that we needed. Jim Ingram. Jim had been an electronics manager in the 650 program. So he came from experience in the vacuum tube world, but of course he was moving into the solid state world as well. Jim was a calm, soft-spoken, somewhat perfect for this job because we had a lot of new things and surprises were sort of occurring frequently, but Jim was very persistent to make sure that the right things were done. I think the best thing I can say about it, Jim met all of the objectives we set for the processor. I want to talk a minute now about printers. Printers are crucial in the unit record punch card environment. And IBM nor the industry had distinguished itself in high-speed quality printers. There were some high-speed printers out, 500-600 line a minute, so-called drum printers, but the lines were wavy that were printed by these printers, and we didn't think too much of them, frankly. But now, IBM had a new technology coming from the ad tech part of the lab down in to become a product program. The program used, instead of the type moving vertical to the print line as you do with the drum, the type moved horizontal with the print line. And so the vertical alignment was excellent, and it was a high quality printer. It would run 600 line a minute, and when you analyzed it, it obviously had potential to go even faster. It made rather minimum use of mechanism and depended heavily on some good electronics, which is good in those days. Excellent paper handling carriage. We don't think too much of that. Most people, when they think about a printer, well, how many lines a minute? But paper handling is very important because most printing is print a few lines on a bill or a check or an invoice or what have you, and skip. It did that extremely well. The throughput was great, and it was cost effective. Initially only planned as an offline printer for large systems area, tape to print. Create tape on the big system, tape to print operation offline. We analyzed what became the 1403, called the chain printer in development, and we made a very, very bold decision. We were going to go with the chain printer. Frankly, we had no alternative. And we did, I must admit, question a little bit that decision when 6 months before announcement, the 1403 was breaking the chain that carried the type around in front of the print line. My good friend Joni Dager, who managed the development of 1403, was what we younger people in the lab at the time called one of the old-time senior engineers in IBM. He had joined IBM, I think, in the early 30s, was just an absolute wonderful guy, great sense of humor, and of course, a good engineer. And he remained calm through all this. A lot of people were creating task forces and getting new materials people in and experts in to correct this problem, and meanwhile, Joni was just continuing. He had great confidence that he was going to solve this problem, and he did. And the 1403, we talked about discontinuity earlier. 1403 introduced a discontinuity into the printer world. It created a new standard that lasted for many, many years. Now, Joni told me, well, 1403 is the key to the 1401 success. I said, Joni, the 1401 is the key to the 1403 success. We agreed that we were both right. Memory, I want to talk just a minute about memory, because that was a precious resource, as I talked about. Fortunately, again, from our standpoint, our timing was good. IBM had had a significant effort in ferrite memories for some time. Much of it had been directed for large systems, large memories, high speed, and what we wanted was fairly low speed to medium speed, but we wanted cost reduced, low cost. We established a small memory group within the 1401 program to work full-time with the memory design people, focusing just on our needs, testing, evaluating, providing feedback, and focusing full-time on cost. The result of that combined effort was that for the cost target we had set, we got an 11.5 microsecond memory, whereas we had said we needed at best 13 or better, and we got 11.5. So we were very pleased. Moving into electronics a little bit, here again, we were fortunate timing-wise. IBM had been working on the solid-state electronics since the late 40s, and had done a lot of research work on materials and progressed through research and design work on devices and so on. And by mid-1957, they had progressed to the point where they were working on 3 standardized circuit families: high performance, medium performance, and low performance. These all would fit on a standardized printed circuit card that could be automated, and there was 2 standard packages underway for small systems and large systems. And so we chose the medium performance circuit, which met our needs. It made heavy use of diodes, and we felt that the costs would come down more rapidly on diodes, and so that turned out, by the way, to be the case, so it was a good decision. I should note that in 1957, Tom Watson Jr. directed that all future IBM products be completely solid state. This caused some heartburn for the printer program. The print magnet driver in the printer program required 7 amperes spike to drive the print magnet drivers, and initially they could not find a solid-state device to do that job. So they put together an appeal to the Director of Engineering, and we joined them to give us an exception for the print magnet drivers. Ralph Palmer, Director of Engineering, said no dice. He refused. And so they proceeded a significant effort, and we helped in as we could, working with an outside vendor, and wound up with a power device that did a good job. Card I/O, I won't spend a lot of time on Card I/O here because I had worked with Larry Wilson for many years developing new technology for cards and punches and so on, and products as well. And so when we wanted the 1402 system or card reader, we were able to put that together with technology that Larry had almost on the shelf, much of it. I want to talk just a minute about market planning. We had good fortune again. Shel Jacobs was assigned as the market planning representative for the Space Machine. When I recommended terminating Wham, the then product planner in the U.S. wrote me a 2-page, all-caps memo telling me how stupid I was and that they would bury me with their objections. Shell came on board. He assessed the space program. He bought into the objectives, and he proceeded to get a lot of additional information to help us. The profile of the unit record installations, the size of those installations, what applications were they running? Very importantly, what were the people skills in those installations? And so Shell was a very important member of the team. I'd like to spend a minute on Endicott IBM team. The lab had a veteran lab director, Jim Troy. He had been in the lab and in the headquarters and back and knew what made the company tick. But the best thing, young engineers like myself at the time, is that we all understood and knew that if you reached for something significant, to do something significant and maybe reached too far and failed, that Jim Troy would support you to the hilt. And so it was very comfortable working in his lab. Over in the plant, when the 1401 started over to the plant, Bud Thuy was there, and then Frank Paul came, the plant manager later. Only thing I can say is they did an outstanding job on the 1401, in spite of the fact that we threw them some curves. Many of you have been on engineering programs. You lay out the plan for engineering changes, and we did that, but we probably gave them twice as many engineering changes as we promised. On top of that, it was suggested, let's say, rather strongly, that they double the first year production. They had planned to build 850 systems the first year. They built 1,700 1401 systems the first full year of production. Just a minute about the rest of Endicott, Customer Engineering Headquarters. They had a small group in each laboratory that worked with the development people from a maintenance standpoint. During the development, they, of course, were interacting and suggesting ways to make it easier to maintain and maybe less maintenance required. At the end of the road for announcement, they had to arrive at a maintenance estimate, which was a very important part of the cost estimate. Cost estimate wasn't just manufacturing. Since we were mostly in the rental business and maintenance provided, the cost for the maintenance was very critical, and they did a very good job. We had a few discussions and debates, but they did a very good job. Finally, product testing. In those days, IBM had an independent organization that reported outside the laboratory to the president of the division. It was their job to test any new product and assure the company that this product will meet all the specifications said for it and before it could be announced. It took us a while. They really wrung out to 1403, the 1401 too, but printers had been problems at time, and so they really focused hard on the 1403. Challenges. We had a few challenges. I've already mentioned cost. It was very important that we make our cost objectives because the thousands of potential customers out there would not come on board if we didn't get the right rental target. Workload on the key members of the team was a very, very big problem. One reason for that, frankly, we had a bunch of self-starters. When there was a problem, they didn't wait to somebody to tell them what to do or anything like that. They went and took care of it. And it didn't matter if it was in the lab or over in plant. As a matter of fact, when we began to go into production, we had several people in the lab that worked the first shift in the lab and then part of the second shift over in manufacturing. And there's a lot of stories about what went on there. Another little challenge we had, most of the time there was somebody in the model shop with the machine being debugged and so on, but there didn't happen to be anybody in there at this lunchtime. Person in the room next door with the partition above saw smoke coming up in the model shop room. And he quickly went in, and sure enough, that print magnet gate I was telling you about with the 7 ampere spikes was boiling out smoke. Quite fortunately not blazing yet, but we almost lost the only model we had of the 1401, and that would have been a catastrophe. We kept touch with the IBM Europe because they had kicked off this thing in some ways, and UK company contacted us and said, we have a fundamental problem with 1401. There's a banking application, Sterling Arithmetic, that almost all the banks use. It's a fundamental application. We have tried to fit it into your maximum memory size 4,000 positions of memory, it will not fit. So he said, bring the information over, we'll take a look at it and see what we can do. And so they came over, and our guys programmed the application. I'm sure Fran had quite a hand in that. When we got through, we had used 3,300 positions of memory, so we were all delighted. Forecasters, Shell will talk about forecasting. They were somewhat of a challenge, as you'll hear. Marketing demos, the response in the field of 1401 was so strong and powerful that they wanted to see something, marketing demos, and we had one model, actually. And again, IBM Europe came forth strong and said, hey, we got to demonstrate the 1401 at the Hanover Fair, the world's largest industrial fair. So in April of 1960, we had our engineering model of the 1401 at the Hanover Fair, and fortunately had a very, very fine demonstration, and the 1401 was extremely well received. Let's talk a little bit about follow-ons. The 1460 was sort of a natural follow-on, more memory, more performance, and not anything to spend a lot of time on. The next lower end entry point for the 1401. It was a system started here in the San Jose lab by my old boss from Endicott, Larry Wilson. He now is in the San Jose lab, and it was not 1401 compatible. And the director of engineering in White Plains suggested that it be moved to Endicott and be made 1401 compatible. And so that was done, and it became a lower entry point for the 1401 family. The next system started in San Jose as well. I think they called it the 306, something beyond the 305 they had built. And the director of engineering again said, move this processor to Endicott. We don't want all the labs in the company building processors, so it was moved to Endicott, and I'm sure he expected it would become 1401 compatible. However, the group it went into were very interested in scientific computing, and so they proceeded to define a machine that was a fixed word machine, very hot scientific machine, very little resemblance to the 1401, certainly wasn't compatible. So my boss in White Plains at the time, Don Spaulding, and Bob Evans, who was the manager in the Endicott lab of that project, took a small group of people from the 1401 program and that scientific computer program to Rocky Point Inn up in the Adirondacks, off-site meeting, you know, flush out all the particular interests. After an intense couple of days, Spaulding and Evans decided that this machine would become compatible with the 1401 and would be called the 1410. The 7010 was simply an enhancement of the 1410, so I don't have a picture of that, but I would like to mention that final meeting at Rocky Point Inn. When the decision was made to stop the scientific computer and go to 1401 compatible, there was a brilliant young mathematician there. I had known him for a while, and he was not particularly articulate, but he made his point there. He stood up and said, I have 1 share of IBM stock. When I get back to Endicott, I'm selling it because this is the beginning of the end of the IBM company. As you might expect, the 1401 success created a target for competitors. The usual competitors, Sperry Brand, Burroughs, NCR, RCA, and so on, and a lot outside the US as well, Europe and Japan. But one competitor was somewhat of a surprise to us. Honeywell came out with something called the Honeywell 200 with a Liberator. This Liberator would run all 1401 programs as is. And so their pitch to the customer is that we can liberate you from this terrible 1401, you're locked in. And the Endicott people were skeptical. They didn't think it would really work, but Jim Dazell, who became a very good friend of mine later, he was Eastern Region Systems Manager, he managed to get into a demonstration of the H200, found out it absolutely ran 1401 programs as is. That led to a crash effort in Endicott to get 1401 emulation on the low end of the 360 line, which was months, 6 months maybe away from announcement, and did not have 1401 emulation at the time. And they did find a way to put emulation on the low end of the 360 line, but the 1401 group in Endicott said that's not going to be good enough. And so they defined something called the 1401 Super, 1401S. There proceeded to be quite a battle between the 1401S and the System 360 Mod 30 with emulation. John Hanster, who started in the San Jose lab, by the way, was running he was division president at that time and had the Endicott location, which had both the System 360 Mod 30 and the 1401S. John made his own analysis, decided that we had to do the 1401S, and so there was a big battle with the 360 group and John. Naturally, the 360 was a big deal for IBM, and it was not going to be changed or altered very much. And so John lost that battle to the System 360 Mod 30 with emulation. Several months later, I don't remember exactly how many, John left IBM and became the head of computing for the General Electric Company in Phoenix. Let me just mention the 360. The 360 was a huge success across a broad spectrum, low to small, business, scientific. But much of that success was above the entry area of the 1401. And this led IBM in about 1970 to create a new division. And only integrated division at IBM focusing on computers had their own manufacturing, development, marketing, and service, headquartered in Atlanta, to reestablish IBM in the true low end of the computing world. And they were very successful, by the way. System 32 through the System 38, the Series 1 mini computer, and finally, just before they were reorganized back into IBM, the IBM PC came out of that division. In summary, we strongly focused on the unit record installation as our target and kept our focus on that target, and that helped us a lot. We met the cost and the system objectives for the 1401. It became a true price performance enhancement, not just more function for more price. And mentioned a couple of quotes out of a book, IBM's Early Computers, that said the 1401 provided, quote, the first realistic glimpse of the size and importance of the computer market that was unfolding. Another quote from that book said, the 1401 opened the world of electronic data processing for the first time to a broad range of users. System 360, I'll make one more comment about the System 360. I said it was very successful. We feel that the 1401 made a huge contribution to the 360 development. We paid for it. Thank you. 9 years after we shipped the first 1401, I was sitting in my office in White Plains when I was the head of System Development Division. Got a call from a marketing exec. We were diagonally across the street. Said, I want you to come over and meet with some customers, which was not unusual to get that call. And I said, I looked at my calendar. I said, I can be over there in maybe 20, 25 minutes. They said, that's fine. I said, wait a minute. Give me some information. I don't want to go meet a customer cold, not know what's going on. They said, no, you don't need to know anything. Just no preparation, just come. I was a little skeptical of the marketing people, of course, but I went over there and the marketing people introduced me to two people from Time Life Chicago. One of them said, I was the individual at Time Life Chicago responsible for installing the first 1401 production machine. And I was thrilled to get a chance to talk with him, and we chatted a little bit, and I said, by the way, do you mind if I ask you 2 or 3 questions? He said, no, go ahead. I said, what was your initial reaction to the 1401? He paused just a short time and said, the ease with which it was installed. So we had had new systems before and what have you, and most of the time we had quite a bit of troubles. Said 1401 installation went smooth, and in no time we were up and running. I said, geez, that's great to hear. What was your next reaction to the 1401? He paused for a minute and he said, people would not believe the minimum amount of trouble we had with the 1401. It just sat there and ran, and he says, it's still sitting there humming today after 9 years. That sounded pretty good, but I had to ask him the next question. What didn't you like about the 1401? I was batting 1,000. I probably should have been quiet. He thought a little longer this time, and then he said, that you didn't give it to us 5 years sooner. The 1401 team changed the business data processing world forever. However, there are several IBMers here tonight who, in one way or the other, played an important role in making that success happen. And I would like for all the IBMers here who played a role in the 1401 success to stand up, please. Would you? There's a few. Right. We're all getting a little old, so we couldn't get as many here as we would like, but I'm very pleased to see the people that did get here, and it's great. I now want to introduce Fran Underwood. Fran, he was the creative fire in our 1401 team. He was interested and knowledgeable across a broad spectrum, but he was really an expert in architecture. You almost never saw Fran without a smile on his face, chuckling about something, maybe even nothing, a glint in his eye. Fran was an inspiration to all of us on the 1401. I'm happy to introduce Fran Underwood.
Well, thank you. Thank you very much. Now that I seem to have your attention, I want to say that I am appalled, or no, not appalled, I'm amazed at the number of people that have shown up here tonight. I don't know where you came from. That was my first question. Where did all these people come from? You look outdoor and you see there's quite a store of people available. Did you just walk in off the street? My second question is, why did you come? Were you looking for a free dinner or something? I don't know. Now I figured out why you came. There's been a rumor going around that I was going to tell some secrets. I was going to wait a minute. I was going to tell some funny anecdotes about the riotous times that we had in development engineering in the 1950s. I think you would be highly amused to hear that, but wiser heads prevailed, and it was deemed to be too risque. So I can't tell you about that stuff. So what's left? Not much. So I'm going to relate some tales from the dark side of engineering. I noticed that there are a large number of youngsters in this audience. Now, a youngster to me is anybody younger than, say, 65. The reason for that, if you are older, you can appreciate the level of technology and the mindset that we had back in the 1950s. If you're any younger than that, you can read all you want, but you'll never understand really what it was like. You had to be there. And I was there. That was great. Now, I was known or called the chief architect of the 1401. Well, as a matter of fact, that's a made-up title. It's not official. It implies that there are lots of other non-chief architects floating around. Well, there weren't any. However, the majority, I mean the vast majority of the people on the program were very inventive and innovative and creative and enthusiastic. That's one of the things you'll hear about this program, if you listen, is the people on the program note how what a great camaraderie we had with all the people involved. It was great. Now, so I was the architect. Well, I wanted to tell you how I got there. I was trained in high school as a toolmaker in Binghamton, New York, with the idea that once you get through this technical course, you would be hired by IBM as a toolmaker. Well, that was right up my alley. So when I completed this course, I was a competent toolmaker, inexperienced. I had no experience, but I was competent. As soon as I finished high school, the war was rolling along very nicely, and there was a need for Navy pilots. The Navy had its own Navy Air Corps at that time, and I joined the Navy V5 program. This is where you are hired or enlisted. They would send you to a year of college, and after that you would go to flight school and complete your pilot training. So I did that. At the end of the year of college, the Navy discovered that they weren't losing pilots fast enough. They didn't need any more. So I didn't get to fly. But I'll tell you what they did. They sent me on to finish my 4 years at college. So they sent me to Cornell University at Ithaca, New York. And I was there for about a year and a half. And the war, I think, ended about then. And so they told me that if I wanted to complete college, I would have to sign up for another 4 years and spend all that time at sea. Well, I didn't want to do that. Gee. So I said, no, I'll quit now before I get my degree. It doesn't matter. I've learned awful lot of stuff. I'm smart enough. So when I got out of the service, the first job I got was as a tool engineer with a small company that did tool design for companies around the area, one of which was IBM. And I got the task of designing all the tooling for the 407 printer. And the drill jigs and the milling fixtures and the assembly fixtures and so on. But I was only getting 75 cents an hour, and not very good. So I thought, well, I'll just hike down to IBM and apply for a job as a tool maker or a tool engineer. Well, I got down there, and they said, well, we'd really like to have you consider being a customer engineer. Engineer? Okay. I don't know what a customer engineer is, but engineer sounded fine. So IBM was starting a new kind of class, a training program for customer engineers. Instead of going to class and learning to, listening to lectures and so on, we'd actually go out on the manufacturing floor and assemble each and every product in the product line, building 5 examples of 5 heat punches, 5 interpreters, 5 collators, or so on, and do the final test on these machines. So that program lasted a year and learned an awful lot, but I couldn't put it all together. I learned this stuff, but I didn't know why I was learning it. You know, I didn't know what I was going to do with this knowledge until I was on the last machine on the 402 line doing final tests on this 402, and the guy that was teaching me made some off-the-wall remark. I have no idea what it was. But all of a sudden, boom, everything I had learned just popped into my mind. And I understood what these machines were, what they were for, why they were important, and all that stuff. So I had no more problem after that. When I started the course, I couldn't find my way through a 2-relay circuit. I just didn't know how to do it. But after that, I had no problem with circuits of thousands of relays. So I was assigned to the Washington, D.C. office and as a customer engineer. And my first customer was Veterans Administration. And they had 2 big buildings on either side of the reflection pool that ran between the Washington Monument and the Lincoln Memorial. Each building on each floor had 125 key punches. And so I learned key punches. And then down at the end, they had the regular collators and printers and so on. And I was reasonably happy with it. I was doing good. But I wanted to be a design engineer. So what I did, at night, I had a couple of ideas for a new machine. So at night, when I come home, I would break out the old drawing board and go to work. I wanted to design a calculating key punch, where the operator would key in the operand fields, hit a button, and the machine would automatically compute sum or difference or product or whatever, and punch it in the same card. I thought it was a great idea. So I designed that, did all the circuits, and I also had an idea for a new interpreter, a machine that reads the card and then prints the information right on the same card. And I devised a scheme using print wheels instead of print bars. And I did the complete design of that thing. And so I took these drawings to my customer engineering supervisor and said, look at this. This is what I want to do. Can I get an interview with engineering in Endicott? And he says, no, we can't do that. We need you here. 1 week later, IBM was looking for engineers. And so they sent scouts out to the various offices and for interviews. I managed to wangle myself an interview with this guy from Endicott. 3 days later, my manager comes to me and said, well, they wanted to interview you in Endicott. So he was quite chagrined. He didn't like that at all. So I went up there and I showed the engineers up there at Endicott what I had been doing. And I interviewed with them. When I came back to Washington, it was another 3 days, and my manager had to come to me and said, Fran, you got an offer to go to Endicott. I said, oh, that's great. How much? He said, I can't tell you. He was so embarrassed because I couldn't make more than he was. So I got to Endicott, and I was now an engineer. And the first job was to redesign the 1402 to handle a new extended capacity card, 160 columns instead of 80. And this was done by encoding 2 columns in binary in 1 column of the card. And it was a pretty good idea. But it didn't fly. It's the way things go. But the thing that was interesting is that my manager that I worked for, was a former customer engineer in Russia. And when he came back from Russia, he got involved with large-scale computing machines, or scientific computing machines. And of course, the technology at that time was electromechanical relays, and they were the logic elements in the circuitry. And this man designed circuits that would add, subtract, multiply and divide, do square roots with relays, and he would draw these circuits. I mean, it involved thousands of relays. And he'd do it all by hand, draw every one, and then he would go over it and ink it in and draw all those little circles for every contact point. Oh, it's amazing. But he was persistent, and I guess he was glad to get out of that job. So I was working for him, and he was the big relay circuit designer. During that time, the director of engineering education came to me and asked me to teach a course, an engineering training course, where I would teach new hires to be an IBM engineer, which is different than the ordinary engineer. Anybody else is ordinary. So I said, no, I can't do that. I don't know how to, I'd never handled teaching before, and I can't speak well, and I freeze up, and I'm just a mess in front of people. I haven't improved much since then. Now, so I knuckled under and I took on the job, and it turned out that it was easy because I knew far more than my students, so nobody could question me. So I did that, and then there was a young man named Fred Foss who had taken a course from Claude Shannon at MIT, and Fred came to IBM and taught a course in mathematical switching circuit design. Up till this point, these were all these circuits were designed by seat of the pants. Where can you find mathematics in anything like that? Well, turns out it's a logical problem, and there is a logic mathematics called Boolean algebra. And Fred taught the course. I was the first student, and when he left, I volunteered to teach the next course. And I was okay, so I did. I was still working for my first manager, and I learned how to design circuits mathematically. And when I went to show my manager how this worked, he was totally flabbergasted that anybody could use arithmetic to design a relay circuit. If he had known how, it would have saved him hours and hours and hours of work, right? After that, I offered to put together a computer architecture course and teach that, and I did that. So at this point, I really began an intensive self-study or self-teaching regimen in math and systems design and electronics. Prior to this time, I knew nothing about electronics. To illustrate, when I was in customer engineering training, the 10 guys that were going through this course would meet with the regular customer engineers, say once a week or so, and sit around and sing Ever Onward IBM and Hail to Thomas J. Watson, leader of the IBM. Oh, we had a great song fest. One of these days, somebody wheeled in a brand new product. It was an electronic calculator, had about 2,000 tubes in it, and it was called the 604. And you know, I was just blown away. It was too much for me. So I stood up and I said, who, where, how are you ever going to find anybody to service this very complex piece of equipment? He says, oh, don't worry about that. You guys will be doing it. Well, well, it turned out that when I was teaching engineering training program, I had to teach them the 604. And of course, I'd never seen one before except in that class. So what I would do, I'd read the manual at night and write the course out for the next day, and went that way until it was done. It was nice, it was easy. I was surprised, you know, really. Well, eventually I was transferred to the Advanced Systems Development Department. The people in this department were engineers and mathematicians. And so while I was in Advanced Systems Development, what we were supposed to do is anticipate technology 10 years out and work with the product planners who were assigned to find out what users would want in 10 years. And then we would sit down with them and we screw around, pretend we knew what we were talking about, and say what things were going to be like in 10 years. Boy, were we wrong. Well, while I was in that department, I had the opportunity to design many data processing equipment, both mechanical and electronic. They were just exercises, really. You know, we had no intention to really turn them into products. It was just trying to get ourselves in place for the future. And about this time, I'm fuzzy on these time relationships. I'm fuzzy on a lot of things. The WAM program was started up in Europe by the German lab and the French lab to design a powerful accounting machine to meet some stiff competition from Bull Gamma company in France. So they put together this proposal, and they worked on it hard, and they did well. But you know, they made one fatal mistake. They designed their product around a control panel, a plug board, of all things. Well, at that time, I'm saying, you had to be there to understand why these people would do that. That's the way it always had been done. It's been that way for 65 years. It's got to be the right way to do it. It's always worked. But they refuse to recognize how restrictive and expensive the plug board was. Not only was it expensive to build it into one machine, but it was horribly expensive for the customer because he had to buy a lot of plug boards and a lot of plug wires, and he had to plug them up for every different application, and that was very, very burdensome. And I spent 2 or 3 years in the field, and I got to the point where I could handle control panel pretty well, but I didn't like them. They were terrible things, just terrible. Particularly in mid 1950, decade, 1955. These people were trying to build a machine around a plug board. And they weren't being very successful. They couldn't meet the cost requirements. They couldn't meet their performance requirements. So somehow, I don't remember how, but I got involved. I was working on some ideas for transistorized accounting machines, and I had heard about the WAM, and I got to look at it to see how it was built and how it was programmed. And I was okay, so I was appalled when I looked at the circuitry, absolutely appalled at how they handled the control panel. It was huge, had to be, and it was all driven by electronics. It had to be. And all the electronics that drove the control panel didn't do anything but that. No logic. They didn't perform any logical function at all. Didn't help the customer solve his problem. It just drove this control panel so that if you randomly plug wires into the control panel, input to an input or an output to an output, an unprotected plug board might blow up. So they had to put in all these protective circuits. And gee, to spend 45% of your money on this old thing was just appalling. So I said, from now on, no more control panels. Let's not have any of those things. We can use the money in a much better way. We can go to the kind of technology that you see in the large-scale binary computers, go to a stored program, and by stored, all these processes of accounting, of course, are programmed, even if you have a control panel. You program the functions through the control panel. But they're very limited in their facility. So if you have a stored program, you put the control not in a plug board, but back in the memory where it's treated, it can be treated just like data. It can be manipulated, it can be executed at high speed, and I thought that was the way to go. Now, now, I devised such a system in about 1957, and I called it the Space Machine, Stored Program Accounting and Calculating Equipment. It's a nice name. At that time, the race for space was all the rage, and this called the Space Machine just seemed to ring a bell, and everybody liked that. I thought it was important to give it the right name. I had a ball there in ASDD with the Space Machine. It was my own little project. I could sit there and I could hug it and pat it and slice it and dice it and paint it, anything I wanted to. Nobody was telling me what to do. So I turned out the 1401 architecture. And people just flocked to it. You know, they thought this was just marvelous. They were enthusiastic. All these people that were so talented, I do not know where they came from, but like I don't know where you came from. But there they were, and they showed up on the doorstep, and they made tremendous contributions in invention and enthusiasm, and that was so important. You heard that over and over if you talk to these people. Now, I had to prove that the stored programming architecture that I had devised would actually solve accounting machine problems. So we had a target. It's called the French banking problem. Very unique kind of processing requirements were involved. So I took that application and I programmed it by hand. I drew the flow charts and wrote the code, all the machine language, and did it within 1,400 characters of memory. And the WAM machine couldn't do that. There was another competitor in San Jose, and they couldn't do it either. So they were out. Now, to give you an idea of the power of the 1401 instruction set, somewhere around here there's a printout listing all the powers of 2, starting with 1, next line 2, then 4, then 8, 16, until you got a whole page full of characters, 132 characters. To program that, to read the card, put the 1 in memory, set the word mark, compute, print, takes 9 1401 instructions. That's all, 9. And you can write them in 5 minutes, you know, it's very easy. Today, if you want to do that same job, you can spend hours trying to figure out how to do it, or you can use high-level languages, and by the time you're done, you've executed tens of thousands of instructions just to print the number 2. Yeah, terrible. Well, we had a lot of fun, so those are tales from the dark side. I want to introduce Shel Jacobs. Shel was one of the, by far, the most important person on this program, in my view. We had difficulties with the corporate forecasting to get favorable forecasts. And good old Shel, he comes in and he just beat the dickens out of them and saved the program. Without him, there wouldn't have been a thing. So, Shel Jacobs.
Well, I'm from the other side of the development lab. It was called planning. Came out of a Chicago sales office, hardly knew what planning was, and very rapidly they got me converted. I really believed in that machine. Planning really broke into 3 parts: market planning, business planning, and announcement preparation. Market planning, you've heard from Chuck, from Fran, but what our users look like. Punch card operations, lots and lots of cards. I had one customer who only used 40 columns. Cards were expensive, 99 cents a thousand. And they built a battleship, 6 feet tall, triangular, and they'd use the first 40 columns of the card the first 6 months of the year and store it in the battleship. Then they'd go to the other side of the battleship and take the other cards out, and that battleship would give them a 4-year supply of punch cards, sheer mass volume. Punch cards, sequential steps: key punch, verify, sort it, collate it, calculate it, tabulate it, summary punch it, and every time you move to a machine, put in a new control panel. Took a lot of time, very labor intensive. I have wired panels. When they told me there was no panel in space, I'm a believer. From an operational standpoint, very serious space demands in the customer's operations. For the files, for the people, for the panels, for the equipment they had to use. Now, having learned a lot of this in the territory in Chicago, I decided I had to go out and find out how these customers would accept the 1401. So I went to a lot of branch offices and I tried to find the most complex punch card applications that I could find with volume printing. And I talked to customers and say, what do you want? Now, the typical customer reaction was, what I got, more of it. And I come along, and here's a thingamabob. Now, how do you like this thingamabob? You've never had it before. You've never used it before. I don't know the price, but how many are you going to buy? So we had some very interesting challenges. Fran's already pointed out that he did the program, the paper programming of the French banking program. I brought some of these applications back. And they tested them again and again. And in every case, it met or exceeded the requirements. Having satisfied that we had a good fundamental design, I then tried to get some internal reviewers. Now, the problem I had in going out was we had security problems. I cannot tell them about this new machine because that would be pre-announcing. And there was a little organization in Washington called the Department of Justice that didn't really like that very much. So I found users within the company. We set up interviews with them. We swore them to secrecy. And we asked them what they thought of the system's capabilities. What about the operational restrictions? How do you like the programming that we're using? We interviewed them. I'll give you a little one. Variable instruction length. First thing we found out was when we finished one instruction, we didn't turn it off and reset it for the next instruction. And the guy said, I don't know how many lights to look at because the old lights are still on. So he said, turn off the old instruction. A simple illustration, which we got by talking to some of the users. Having satisfied ourselves that we were on the right track, and then went to the next phase. We had test classes. We knew we had a massive educational job on our hands. And courtesy of Jan Swanson, she wrote the manual. And we went out and ran classes, internal users. I went to the Service Bureau, customer engineering, sales training, systems engineering. I got beginning students, advanced students, and we taught them the class. I had machine operators from the Service Bureau, field engineers, administrators. I started out with the programmer's aptitude test. Programming was just coming in. We didn't know if it was any good or not, so we had a test at the beginning of the class. We then simulated a customer training class, and we gave them an exam. And we graded them on their reaction to the programs that we had taught them. And there was a phenomenal correlation between their programming aptitude and the results of the tests. We interviewed them to get reactions and the effectiveness of the training. What I've talked about was done on an iterative basis. We try some, go back to the lab, retry it, fine-tune it, and things of that nature. Then I got into the business planning side of it. Business planning is a series of checks and balances within the IBM Corporation. They had to worry about product test. I had forecasting, pricing, legal, marketing training, every aspect of the IBM Corporation, and I was frustrated. And you've heard Larry Wilson's name mentioned. I came back from White Plains one time in a high level of agitation. And he said, what's wrong? And I said, so-and-so did such and such. He said, Shell, if you ever do an efficiency analysis of a newborn baby, you'll kill it at birth. Painful, expensive, screws up your social life, ties you down. Remember, there are a lot of baby killers in group staff. That changed my whole perspective. So I started working on the business case. Just a parenthetical explanation, the business case was based on United States forecasts. We recognized we had a worldwide market, but the baby killers didn't know how to integrate it. So they apportioned costs and applied ratios to the revenue. So we did the US numbers and did that to the rest of the world. It worked. I started out by developing a planning sales estimate. It's called a PSE. I had a printout of the installed machines in the United States, the number of accounting machines, the number of calculators. I sorted them down by installation size. We used how many of you know what a point is? We rented our equipment. A point was $1 a month. And everything we were talking about was number of points. So I went back out and I probed where the break-even point was. And we went back again and again and again. And basically, we found out that we got into 2 tabs and a 602A below the 604. It was kind of touch and go. You got 3 tabs and a 604, go for it. And on the basis of that, we found out at 2,000 points it was close. So we set our target rental for the entry-level system at 2,500 points. On the basis of that, I extrapolated that against the installed base and came up with a planning sales estimate in 5 years of 11,000 systems. I then went back to my favorite baby killer, the forecasting department. He emphasized every negative aspect you could think of. You can't believe customers are smart enough to accept and understand stored programming. What do you mean you're going to displace calculators? You have multiply and divide as an optional feature. Why? Because it could do it on a subroutine basis at no lost time. And on other machines, you would read the card into the calculator, calculate the result, punch the answer into that card. On the 1402, you'd read the cards on one side, calculate it, and print it. Why punch it? So I decided I've really got to educate this guy. So I still remember when I invited him to go out in the territory with me. We went to the New Jersey Department of Unemployment. And we're in there, and it's a classical profile of the top prospect. And my friend said, do you have any jobs where you read the data from the card, calculate the result, and punch it into the same card? He said, well, of course, that's the way we print the checks. And I said, so if you had a machine where you could read the data, do the calculation, and print it without any loss of time, would that be acceptable for you? He said, of course. And I showed him. And we get outside, and I said, boy, that's a sure winner. He says, what do you mean a winner? You'll never sell them. What do you mean you won't sell them? He said he wanted to punch the answer in the same card. I said, yeah, but I explained to him what the alternative was. He says, yeah, but you're more aggressive than most salesmen. Me, aggressive? I did everything I could think of to convince him. And he came out with the 5-year announcement level forecast of 2,200 systems. That would not support announcement. We had to justify oversimplify. You spend $1 million building a machine and you sell one. Your cost base is $1 million. You sell 1 million, your allocated cost is $1 a machine. I've now got it bracketed. It's somewhere in there. Well, I couldn't let him get away with this. I had to help him understand. So I filed a formal non-concurrence with the forecast. We escalated to an independent body for arbitration. And while we're doing that, I went in the back door. I went to group pricing. And I said, if these are the costs, what kind of volume do you need in 5 years to give us our price objective? The answer? 5,200 systems. Miraculously, the arbitration committee agreed with an announcement level forecast of 5,200 systems. Wasn't that a coincidence? But my friend in forecasting wasn't finished yet. He said, you got to understand something. You got a lousy business case. You're going to have a 100% impact program. For every system you sell, you're going to knock out an equal amount of punch cards. You'll net 0 growth. Boy, there's no stopping them, is there? So I went to my friendly engineers, and I found out, assuming we had X number of points to build, what would it cost to build it with the 1401, and what would it cost to maintain it at that level versus comparable figures for unit record equipment. And on the basis of that, we could build the 1401, absorb the development costs, and do it for lower costs and higher profit margins. So we got announcement support for the 1401, you'll never believe this, not as a growth product, as a profit optimization product. Whatever works. We then went on to announcement preparation. We had a big education job to get the field to understand the new concepts. We took a lot of the case studies I'd done and we turned them into application brochures. We had educational material available at announcement. We worked with outside agencies on preparing press releases and advertisements. We emphasized the chain printer. We made print samples available. Everybody wanted to know, what is this magic chain printer? So we went to the test lab and chunked out thousands of copies. And then one of the things we emphasized, was alluded to, that we had short form eject. Look at a check. How many lines of printing are there versus how much blank space? And we could move the paper through faster. And then we did something that was a first. First time in the computer industry, and as far as I know in any industry, we prepared a videotape. The development system was in the test lab. If we pulled it out of the test lab to make the videotape, we'd blow the schedule. So we got creative. We took a 1402 machine driven by a robot. We took a 1403 printer driven by a robot. We put the robots behind a drape. We took the 1401 CPU box. You hear what I just said? The box. We put flashlight bulbs in the console. We had tape drives. They arrived that morning. We didn't have time to connect them. You look at the videotape, they're spinning like crazy because there are engineers behind them spinning the wheels. We got the announcement videotape ready on time. Announcement day, October 5th, 1959. The dawn of a new era. We had a closed-circuit video announcement, 102 locations to an audience of 50,000 people. It was supposedly live. I was in Chicago, and we were showing the speed of the printer. And the guy said, look, we can do 203 bills a minute. And the guy in front of me says, who are they kidding? And the guy's peeling them off. He says, who are they kidding? There's more than 203 there. He said, no, there's not. I counted them. What's happened since? We achieved the announcement level forecast very rapidly. And in spite of my friend in forecasting, very high yields, a lot of growth. And suddenly we found we had something else that we didn't really understand. They were called low-end tape systems. The tapes were announced primarily to facilitate the printing from higher speed systems. And our customers, our customers said, hey, we don't need that battleship of punch cards anymore. We can put them on tape. And the customers started accepting tape systems. So since then, we've seen the tape systems grow. We've expanded the memory. We've had disk drives attached, the bank reader sorter. The 1401 peaked the inventory, the acceptances at 15,000 systems. We had the family grow to the 1440, 1410, 1460, 7010. I'll sum it up by saying the space program launched very successfully.
Like all good engineers, we overestimate our schedule. We're, so was that worth that time? Okay. Now, since we are running a little late, I'm not going to have a panel session, but if you have any questions, write them on the cards and we'll take a few questions when I'm done. Do people have time for about 10 more minutes? Okay, I'm going to go through the restoration project really quickly. We got the team here. They all said yes. If anyone wants to get up and stand and stretch a little bit, that's okay. I won't be concerned. So in the next few minutes, I'm going to brag a bit about the 1401 restoration project. You can see that the energy just keeps us going. It started here in 2004, and I guess I've got the clicker now. So here we are, all posing in our oops, that's the system. But here we are, all posing in our IBM best dress. We're all volunteers, and in this picture, we're dressed normally, albeit not spotted with grease and oil. And what can we complain about? There are no deadlines, 100% salary increases, and no performance reviews. So why would a team of volunteers show up for 500 work sessions to restore a 50-year-old computer? Well, Johan Johannesson, who we talked about earlier, composed that symphonic music. In his interview with NPR's Mark Berman, said that his music was a kind of respect for the ancient. And if a piece of technology has become redundant, it doesn't necessarily lose its worth. So what is a 1401 worth today? Well, if I can get the thing to stop. We see its worth in the eyes of our visitors. When they experience the 1401 running, or CompuSoar as I call them, they seem to believe they've just stepped into a time machine. And with a little imagination, visitors can become inspired to conceive of a future as different as the 1401 was from today's electronics. As Alan Kay, a museum fellow and creator of computer languages for young people, noted, that once you have that inspiration, he said, the best way to predict the future is to invent it. By the way, Alan's first formative computer was a 1401. And the next picture shows that we invite visitors to touch and operate our ancient key punches. They have kind of this visceral ka-chunk feeling as they punch a hole through a rectangular hole through a perfectly rectangular hole in a punch card. So why did we acquire not just one, but two 1401s? Well, Arnold Schweinberger stored his in his garage for 28 years. He's the gentleman on the left, after using it for billing services for 5, and purchased from an insurance company. His son, Rolf, on the right, assisted, and IBM arranged and paid for its creating and shipping. Buzz Belflor stored his 1401 in the basement of his home in Darien, Connecticut, for 12 years, using it for billing services, and he used it up until 1995. After purchasing from an insurance company, people must love this machine. And again, IBM paid for its transportation. In this picture, in the right column, you see that the whole family grew up with electronic data processing in their home, PJs and all. It's just amazing. But the big issue for us was how to get the 1401 up and out of his 36-year-old basement, chambers I called it. Here, Frank King and I on the left, and Scott, Buzz, and Ray on the right are contemplating the basement. With the help of a local rigger and a 20-ton crane, and of course a rainy day, the 1401 was triumphantly extracted from its den with nary an inch of clearance. You can see in the middle picture it had to get out that hole. After the Connecticut 1401 arrived at the museum in 2008, it had an unexpected influence on its German sibling, which we had been working on for 4 years. Perhaps discerning some slight potential for redundancy, the German 1401 processor mysteriously began to start working. It was So next I'm going to just show a few pictures of typical day-to-day scenes. The 1403 printer has been remarkably reliable. With an hydraulic fluid carriage, they're more akin to an automotive transmission or an industrial machine. Here the team is having fun adjusting its print quality. The 1402 Reader Punch is from a long IBM Endicott family of reliable unit record machines. You heard that. But our first 1402 was fairly rusty, so its punch was exchanged with another's in the museum. Nevertheless, card jams still make quite a mess. In addition to restoring the electronic 1401, we also restored some very old unit record equipment. Here, a 1942-45 reproducing card punch unit. Sometimes it takes a group effort to shoot a bug. This is the Connecticut 1401. And you can tell who was once a Silicon Valley CEO in this picture. As Bob Farrich shows, we're frequently up close and intimate with our bugs, grease and oil and all. We've also built several bring-up tools, including this PC with an embedded microprocessor and analog electronics that can emulate 6 tape drives. And we're also lucky to have access to volunteer and board member Grant Severe's enormous machine shop where various mechanical parts can be refabricated and restored. And here's Alan Palmer working on a magnetic clutch for the tape unit. Now this looks a little complicated. This is the, although it looks complicated, this is the 4 kilobyte or 4 characters you've heard tonight, main memory, 4,000 exactly characters. $25 per byte, by the way, today's dollars, so not cheap. But the whole point of this picture is that you'll see everything is on a human scale. We can actually fix this by hand. Unlike today's integrated circuit chips, all you could do is throw them away. In fact, our 87-year-old volunteer, Bob Erickson, has repaired broken wires in core memory. And here's Bob examining a 12,000 byte extended core memory unit. And in this picture of the SMS card, you can tell that the components are replaceable. In fact, some of them are just wires. Now those don't luckily fail. And some look like pieces of candy if you look at them closely. And believe it or not, the transistors are along the top there. We can still find new old stock of old germanium transistors on the internet. Speaking of the germanium transistors, by the way, these are the semiconductor germanium, not silicon. We live in Silicon Valley, so it's a bit unusual. This is what they look like on the left with their heads taken off. And to me, they remind me of the old Whisker and Crystal radio sets. Now, even though the label on the right has a little map of Texas and a TI symbol in it, these transistors were actually made in an automated transistor production facility that IBM had designed in the late 50s and then transferred to what was just an oil instrumentation company in Texas at the time. And indeed, tens of millions of these could be produced per year. And when Steve Wozniak visited here a couple of years ago, he recognized how an inspired 1401 student could firsthand learn the fundamentals of computing, from transistors to circuits to packaging and up to software. And several folks in the software team have reinvigorated the practice of 1401 programming on laptop simulators, of course. So we needed to provide a memory of what it was like back then to do software in the 1960s. So this is up on the wall now for all those who want to remember the joy. Notice that there's a flow chart in the template in the lower left corner, something you'll never see on a programmer's desk today. That was exciting. So some of the volunteers have fun sending subtle messages. Here's Syphilis rolling the 1401 Works rock up the hill, soon to come back down. And here's our tape guys getting kind of wrapped up in their work. So my last slide, you're never too old. We're looking for attracting new young volunteers, so some talk to me afterwards if you'd like to volunteer. Okay, that's it. Okay. 3 questions? So we're just going to do 3 questions tonight. So this will be easy. Not a lot. Won't have a lot of chance to think about them. Okay, here's a question from somebody who said, once I helped open up our 1401, every latching mechanism I encountered was elegant and one of a kind. Did Endicott include all the winners of a latch design competition? I've always wondered. So this is in the SMS packaging.
State that question again.
Well, they're asking about the SMS packaging, the gates that pulled out of, of the gate, and they're just saying, it works so nice. Did they have some kind of competition to have a winning design? I don't know. That was probably...
Well, frankly, if that's a serious question, there were 2 standardized packages. That was the small size, the cube machine. When we initially were trying to make a decision about packaging, we went to the people with the cube machine and we wanted some changes. And they said, this is a standardized package and you can't have those changes. We said, all right, we'll go up to the large system package called a roller gun for large systems. And they laughed at us and said, yeah, good luck, you'll be back. Well, 2 days later, we'd be back, and we took the cube, but we didn't get much of changes we wanted.
Okay. Oh, by the way, could we start the video in the background? I've got a silent video which will just show restoration scenes that we can have playing while I do the questions. It won't be 2 minutes. This is an interesting question. I think, Chuck, again, this might be easiest for you. Were there any electronic design automation tools used in the development of the 1401?
Jim Ingham should answer that question, but
he's sitting in the front row. But
yeah, not very sophisticated, but there were some. And later on, of course, it became very sophisticated. But as I recall, Jim, there were some design tools to help us with heat dissipation and wiring and things of that type. Am I right? Yeah. But, you know, later it became very sophisticated. You could essentially tell all about your circuit and circuit design and gate, about temperature spectrum and a lot of things, yeah. But not at the time of the 1401.
Yeah, I think one of the things that we learned from this era is the designers really had to do a lot of this by hand.
Yeah.
The SMS, it was called automatic logic diagrams. You would actually hand draw the schematic, hand it to a key punch operator. They would punch in how it all hooks together, and that would be read into a mainframe, which would then show how it connected up. But there was no automatic timing analysis. My vision was there's a big room of people, and people would say, I need 5 more nanoseconds over here, you know. And it was all done manually. Yeah. And another question I'm not sure who would be able to answer, but is it true that the first packaging use of the revolutionary new material called bubble wrap was for the 1401? Do you remember when they shipped? I don't think.
For that.
Yeah.
I don't know the answer to that.
Yeah.
What's the question? I don't understand it.
Yeah.
Was the first one to use bubble wrap? Oh, I didn't know that.
Can't answer that question.
No. So, Fran, I have one question for you since the video is not quite done. Can you hear me, Fran? So.
Yeah, but I don't understand what you're saying.
Okay. Yeah, it's a little hard in here. How did you make the 1401 instruction set easy to use? I mean, after all, a wire is not the same as the letter A in programming. How did you make it easy for programmers?
Well, the customer base was targeting the unit record accounting machine customer was used to working with alphabetic characters and decimal numbers. Totally different than the electronic computers that were in binary. So I made the instruction set mnemonic in using alphabetic characters and decimal numbers, so it was easy to sit down and remember that A was for add and S was for subtract, M for multiply, D for divide, E for edit, and so on. It was all very simple to understand, and it was user-friendly. It really was.
Okay, I would next like to ask if Scott and Buzz could stand up. Don't clap yet, just Scott and Buzz, are you here? The owner of the Connecticut machine? Okay, go ahead and, all right. And could I ask the 1401 restoration team to please stand up? All right, give everybody a big hand.
Thanks again to IBM for your generosity in supporting us tonight. Thanks to all of you for coming. Please drive safely. Good night.